So in this video, I'm going to be showing you how to synthesize the compound below from acetylene and any other appropriate reagent. So the first thing is to write out the acetylene, which is just going to be carbon to carbon triple bond. This is a carbon on this side, this is a carbon. And on each of those carbon, you have a hydrogen. So what I'm trying to say is this: you have C triple bond C, and there is one hydrogen on each side of the carbon. Okay, so but we're going to work with the line structure, so I don't have to show the hydrogens. Now, the next step is to look at the product and see how it differs from the acetylene. So if you look at this double bond O, this particular carbon must be part of your original carbon of the triple bond. That is an added atom. And for that atom to be added, it must have been on either a double bond or a triple bond, because that is the most reactive point in the whole of that structure. Okay, so that being the case, it means that you can either have originally these two carbons to be the triple bond or this side. So whichever side you end up choosing, the reagent will also differ. Okay, so I'm going to choose this side as the original carbons on the acetylene, these two carbons. And this means that we're going to add this carbon and all these other carbons. And to do this, you will have to remove those hydrogens on the left and the right hand side of this triple bond. We have to deprotonate them in order to add a carbon chain. So we will start by adding the first reagent. So my first reagent is going to be sodium and NH2. This NH2 has a negative end while the sodium has a positive end. So if we write out the hydrogen that is on that carbon, this is going to pick up the hydrogen, okay? And this bond is going to break in, which means that I'm going to have a triple bond with a lone pair and a negative charge. So removal of that hydrogen will create this particular ion. The next step, since we're working on the right, I'm going to be adding that one carbon to that. So that would mean that I would need just one carbon, okay? So remember, this is a carbon. So this is going to attack that carbon, and this chlorine will leave. So at that point, we have successfully added a carbon to the right, okay? So now you have this. Next step, I'm going to add from this carbon all the way down to the left side. So that is 1, 2, 3, 4, 5. I will need to add that 5 carbons. So remember, we said that the original carbon I had, this is the 1, 2, which is the original carbons on the acetylene. Okay. So I've added one extra, this one to the right. I'm going to add the remaining 5 on the left. To do that, I need to remove this other hydrogen. So again, I need the sodium NH2. The sodium is positive, this is negative. So that's going to pick up the hydrogen again, and this bond breaks in. So from there, we're going to have a negative charge on this side of the carbon, and this was still intact. So to add a 5 carbon chain, I'm just going to draw my 5, 1, 2, 3, 4, 5, and then add chlorine. You can use bromine as well. Now, this is going to attack this carbon. It's going to attack that carbon, and this chlorine will be kicked out. So now you would have the triple bond, the extra carbon on this side, another carbon on this side. So that's 1, and then count your 5. 2, 3, 4, and then 5. Okay, so in total, I have 1, 2, 3, 4, 5, 6, 7, 8. Now confirm that that carbon is complete before we move on. So that is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is a complete number of carbon. The next step is to work on this reactive site, the triple bond, because there is no triple bond in the final product. So we're going to work on that triple bond. And this is what we're going to do. We're going to use H2SO4 in H2O for this. Now, what this reagent does is to add OH on the more substituted side of the alkyne. Okay, this reagent follows Markovnikov rule. Now, I want to make a comment. If you had chosen these two sides to be your starting acetylene, then you're going to be doing hydroboration instead. Okay, and now if we move on from there, this is acid. The only thing that happens here is that this is going to pick hydrogen from that acid. Now, when it protonates, you're going to have this. Hydrogen will add to the less substituted side, why this becomes a carbocation. Now, the H2O is going to attack the carbon with a positive charge, attaches itself, and then you have the H2O attached here. Of course, the double bond is still there, and the hydrogen is still here. The last step would be that one of these hydrogen would be removed. Over here, you would have OH. So this would atomerize, and this is what will happen. This arrow here forms the double bond. The double bond here breaks in, picks hydrogen, and that's how it's broken. So there's no longer a double bond there. So it happens within the molecule and takes us to our product. It's called tautomerization. And that's how we form the product. So the final product, if we write it out, will look exactly like what you have there. Unfortunately, I don't have so much space, so I'm going to try to use another color. Okay, that is it.